On the conversation about about ply versus OSB, Cameron and I have actually been talking with CHH, and they're actually sending it over to get tested. So,
good news.
Yeah. So the question on that, would OSB 3 ply or ply would then be better if it is essentially going to be vapor permeable?
Yeah, if it works, of course. I think it's always better to have locally sourced products. The only concern was always because you have multiple layers on glue, which we don't know. We know also now we can use like more vapor permeable glue, which would make it better too. The most important part is if you don't know what you're having in front of you.
Okay, I think where I'm getting at here is because with OSB, you've got multiple strands of little broken up bits of sort of chipboard. If that gets wet, that can quickly distribute across the whole board. Where compare that to, say, a plywood, and you've got multiple sheets of layers of ply, that ability is to dry out because it's separated by each other. Am I on the right track, Cameron? I think we've...
Yeah, so I guess... Will you turn it on?
Yeah, take one.
Nope. That's better. Okay. So if you think about how these products are manufactured, so ply is just a veneer of, multiple veneers of timber, so solid, continuous grains that are maintained, glued together. And so the problem with the vapor permeability of the ply is really what's going on with the glue between each of those layers. With OSB, you've chipped up a whole lot of timber and you've stuck it in a soup of glue. And so if you imagine putting a drip of water on that OSB behind us, it can't necessarily distribute very far. And the more you can allow that drip of water to distribute, the greater the surface area and therefore the greater the rate of drying. So with ply, if you put water on the surface of it, it can distribute along the grains and therefore dry, which is kind of similar to what you have with conventional timber, before you go and engineer it into something. I think there's a lot of debate about this, and Daniel's right, we just don't have a great deal of data on materials available in the Australian market, which is a big problem. If you go into something like the WWOOFy database, so there's a whole bunch of products in there, some from, say you look at the plies and OSBs, there's a bunch of OSBs from Europe, a couple from North America, similarly with the plies. What you generally find is when they're dry, so at low relative humidity, they're pretty similar. And if anything, the vapor permeance of ply is less than that of OSB. So remember, all else being equal, we're looking for more vapor permeability rather than less. But what I would suggest is what really matters is at high relative humidity. It's when the system starts getting wet that you've got to make sure that you've got that openness, that vapor permeability. And so what you tend to see is the vapor gradient of the ply drops off more rapidly, such that it actually becomes more open at those high relative humidities than OSB. In general, the problem is you're getting a very large variation within a family of products. And so we just don't know with the plies, for example, that we've got in Australia at the moment. But I would come back to my other point, and I'll bang on about this ad infinitum, is if you whack on some exterior insulation, even just 20 or 40 mil, and it's vapor open on that system, then what happens in terms of the vapor permeability of that ply/OSB becomes almost irrelevant, because you're just taking the edge off the temperature. Is that about right? Yeah.
Second question, and I think you're both maybe going to disagree with each other here. Treated pine or standard pine battens for your cavity?
Yeah, of course, depends on the climate, but I'm historically based absolutely against treatments for multiple reasons. There's a reason why Germany moved away 40 years ago. So remember, like in the early 60s, 70s, we built up the roofs and we ran around and treated it. But it's a massive health risk. You always have the off-gassing of the materials, and we went away from chemical timber treatment to constructional timber treatment. So it means kind of you build your structures, you can always dry out. And treatment which we know also, we can buy weeks and months, but you can't buy years. So you can't chemical treat a shitty structure. That's what it is. So because the outcome will be always the same. The only thing back in Germany where we actually have pressure-treated timber is because we have snow loads, so you have the avalanches from your roof, so you actually have massive timber lumbers on the roof to actually stop the snow falling down. That's the only case where we have treated timber. So I said, now let your building ventilate properly and don't stick timber into wet areas.
So this is sort of a topical debate we've been going on with for a few weeks around here. But so just to be clear, we're talking about the battens on the exterior face of the sarking. So I would come back to the point about the roof sheet. If we're going to ventilate that cavity, it's a design feature that in so doing, you are allowing all of this air to move in through underneath your cold roof sheet. So you are going to get condensation. It's what you've designed the system to do, inadvertently perhaps, but that is necessarily what's going to happen. And so now if you just got a bog standard 30-degree roof running down the pitch, and you've just got a few buttons running up the pitch there, then you can probably get away with untreated, probably. Where I worry is in the valleys and in your box gutters. So where you're concentrating that moisture that's dripped off to the underside of the roof sheet onto your sarking and now has rolled down and is condensing in the valley, if that gets onto those battens, and it's going to get on at, say, 6 a.m. on that winter morning, by the time the sun comes up, has that system now dried by 4 o'clock that afternoon, such that you start the next night with a dry system? Because it's about the accumulation. If the system gets wet for an hour or two, probably you're okay. If make up a number, we get 10 grams getting absorbed into that batten in the morning. If we get 9 grams of that drying out by the next night, and we get another 10 grams overnight, then we've got 11 grams the next morning, and so on. And so you're going to get that accumulation over time. And so my gut feel at the moment is, depending on the roof size, shape, depending on where it is. If it's on Mount Buller, it's different to if it's in Melbourne. It's different, again, to Sydney or Cairns or somewhere else. But maybe we need to look at treated battens just for those really acute areas.
I understand your concern, but in this case, I would say, because I retrofitted a lot of roofs in Germany back up to 40, 50, 60 years old, and I never had actually the issues, even with the early membranes, that there was a rot problem, because the ventilation always dries it out faster than you actually have the problems. Because like you have the absorbent property of timber, so you actually, the moisture splits around the whole timber, so it means kind of you don't have the spot wetness of the timber for a long time. So that's like looking into old roofs, it never was a problem. Funny enough, always problems is when you have metal directly attached to timber. This way you always have timber rot after 30 years or so latest.
Did you want to rebut him? Last question before I go to the crowd. Why do you guys care so much? Like, wouldn't it just be easier not to care at all?
Maybe because I'm German, that's why.
I live in a building, and so does my family,
Okay, that was very simple. I don't know who has the mic. Hamish was here somewhere. So any questions? Who wants to be the first to put their hand up? There you go, Brad.
Just back on the battens, should we then just be changing what products we're using in those trouble areas, valleys, box gutters, that sort of stuff? Should we just be using not timber as your counter battens and battens in there?
Like a top hat, you mean, Brad, or something like a...
Oh, not a metal top hat, but there's a few different, like plastic products or, like the hairy chest
Maybe.
sort of stuff.
I mean, got to be careful with some of the hairy chest stuff, because as Daniel pointed out, they're providing a drainage plane, not necessarily a ventilation pathway. I think we do. So maybe the way to answer this is, I'm not sure that we have enough data. And how do we get data? So let's get some data. So my latest thing, and this happened just in an email discussion a few weeks ago, is like, right, okay, we need some moisture sensors that actually automatically log that we can just screw into some battens and leave them there for a couple of years and see what happens. So I have those now, $200 a pop. So we're just going to get some roofs, find some of those critical spots, and we'll just... and let's get some data.
What about insulating under if you were just going to do some external insulation, might get it under the valley fans, under the box gutter fan, will that have a big impact on how
Yeah, and are you putting, like, say, XPS hard up against your membrane as well, or are you leaving an air cavity still?
I'd say like membrane, yeah, maybe cavity underneath, insulation, and then your box cutter fan straight on top of the external insulation.
Yeah, so it's sort of, it's becoming a bit like an anti-con type of solution at that point, isn't it? Where you're putting a little bit of insulation hard up against the underside of your roof sheet. Is that kind of what you're suggesting?
Yeah, it's just like, it's always, I hate box gutters, Gerard.
We all hate box gutters.
Yeah, so it's always like, yeah, that conversation. I've had the same conversation with Matt around treated pine, not treated pine, what's the best way to set it up, and, you know, we're always chatting amongst each other. How do you do a box gutter the best, aside from just telling people I'm not building anything with a box gutter?
So just a few radical statements. First is XPS, enclosed foam insulation, in my opinion, has nothing to do anything up above ground. So XPS, EPS insulation is designed for being in wet areas underground to actually insulate basements and cellars. So that's my opinion. It has even less a place in roof structures because it's absolutely vapor tight. So you actually trap moisture. The next part is with the box gutter. You just follow the system more or less, and you just check that the box gutter is at least at 2 degrees. If you go down to 1 degree, I don't want to know. The most important part is that you really run the membrane parallel with the box gutter, and the overflow of the box gutter for the worst case has to be lower than the roof structure starts. It's an important part. Then with the battens, I think if you would use metal battens on the roof, it's again vapor tight and it's a thermal bridge, so you would actually end up with a condensation problem again. If you try to pack it up, I don't like it too, because like battens are actually designed to be consistent because they support the membrane too. Because if you have wind pressure, positive, negative, you want to have consistent support for the membrane. The plastic venter beds, or how they're called, I personally, I'm not a fan of it because I did a lot of retrofitting back in Germany, and the biggest issues have been always caused by plastic materials. And they look relatively cheap to me. I don't think they will last longer than 10, 15 years under Australian conditions with hot areas. So I think like from the perspective, because we build more for 10 years, we should always think in 2 generations. I trust timber, yes, but I don't trust plastic if it's not stabilized, but then you would actually drive the costs up. There's a reason why our membranes are relatively expensive compared to very, very cheap ones, because they're heat stabilized.
So Dan, I'm just going to add to that. Like, if you think about your roof system, it's the extreme in both directions. Now, it's going to get to 60, 70 degrees in the summer under there. It's going to get to minus something in the winter. So it's just like the worst environment for any material. Banging on about my current thing about exterior insulation, if we go back to the membrane stresses, you know, it's compressing, it's stretching depending on the temperature cycling that it's going through. Any membrane is going to suffer in that scenario. You know, the good membranes will last much longer than the crappy ones, no question about that. But if you can just whack some insulation on the top of that, vapor permeable, critically, then you're just stabilising that temperature fluctuation and therefore extending the life of whatever materials are below it.
I actually just want to ask a question then when we're talking about the fluctuations in the membranes that they can stretch and move. And when we run our counterbatten, people are using blocks, and we've done it ourselves. Does that mean that if any wind can get under there or move it, at that sharp part of the corner, we're risking that wrap could essentially rip?
Mine are normally strong enough, but I would be concerned about it because I think they should be continuous, because we want to have continuous support of battens, my opinion is. I haven't seen it. I haven't seen any ripped membranes due to batten patches, but yeah, because we talk about 20, 30 years here, 50 years. Yeah. Just give you my microphone.
Thanks for the presentations, they were great. So far we've talked about building new roofs. If you're retrofitting, which hopefully we'll be doing more and more of the 1970s homes, for example, personal example, concrete tile roof, how do you actually approach it from condensation management? Do you need to? What is the most budget effective way of actually adding insulation in. But you don't want to rip the plasterboard out. In what way do you actually treat it, I suppose?
Yeah, I get the question quite often, for us, like, why we focus on new builds. And Jesse has a quite radical answer that we have to stop building shitty buildings and then we can think about retrofitting. The thing is, like, as we still build buildings to building code, we know also they're going to have massive problems in 10, 15, 20 years. So that's why the main focus is generally on new build. The next part is that retrofitting, from my opinion, needs a lot of experience and understanding. So there are all the systems, they exist. And specifically, if you look to UK, Germany, and other countries, and then you find all the systems that work. Their systems are one way you have to always retrofit a building from the inside or from the outside. That's what you always have to pick. And you can do it from both sides, and you can make it work from both sides. Technically, it's always better, from my opinion, to do it from the outside, because then you actually can create a continuous layer on the outside on weather tightness. So you actually rip it back to the plasterboard, then you just fill up with insulation, maybe you change your cables, conduits, whatever it is. Then you put the insulation in, then you put a membrane on it, and then it depends, a rigid board with external grade insulation, an appearance stick membrane, or just a membrane and normal cladding. And then you put it all back up. But you always, when you retrofit, you try to get as close to a new build as possible. My biggest tip to everyone who wants to retrofit, you have to think black and white, specifically when we talk about the benefits. And I have been invited to so many building sites and say, you really have to draw the line here and be very black and white where your air tightness layer is. And 50% of them didn't even listen to me, and they ended up with a massive shit fight, didn't pass, and had all sorts of issues. So when you retrofit, really define very, very, very clear where your insulation layer is, and don't have the weather tightness layer, air tightness layer, don't jump them forwards and backwards. I had Enerfits to use 5 different products as an airtight layer. It's doomed to fail.
So just the comment about, how do you do something on a budget at the moment? How can anyone build anything on a budget at the moment? So statement of the obvious, I suppose. If it's an older timber frame structure with, timber cladding, timber is a great material, right? It's just so easy to work with and to retrofit. I agree 100% with Dan. Your first port of call is always, what can I do from the exterior of this structure? Can I pull down the brick veneer? Can I take off those concrete tiles, rip off the weatherboards, put a membrane on it, put some exterior insulation on it? That's pretty damn good. Put a HRV in it, absolutely, always. Sorry? Wood fireplace? No, you don't do that. Absolutely do not do that for your own health and your neighbour's health. What else do you do? Windows, thank you. Yeah, okay, so rough range. So Project Matt and I have been working on brick veneer 1980s project home, slab on grade, brick veneer, as I mentioned, clay tiles. That's a tricky one because you don't want to remove the brick, both for cost and environmental reasons. Why chuck stuff if we don't have to? Bricks are in perfectly good nick. So in that particular case, that was an inside strategy. So rip off the plasterboard, get access to the wall cavity, get some decent insulation in there, get an air and vapour control membrane on the interior face of that stud frame, continue it on the underside of the ceiling. So we're getting air tightness continuity through our construction. Get a HRV in there, both for good indoor air quality, that's important, and also as part of your moisture control strategy. How do you deal with a slab? Well, that's going to be project dependent, and get some decent bloody windows in the build. Because if we think about, if you just want to make an incremental improvement to your building, probably air tightness is your easiest one. You go down to your hardware store and you get some caulk and get to town. But any building, you pop out the crappy windows that we have and you put new windows in from a your user comfort perspective, that'll make a hell of a big difference. But if you make it airtight in so doing and you don't have HRV, then you're introducing new problems. So we come back to that building sciences interactions. You mess with one thing, you mess with them all. Oh God, yeah. Right, so this is a pitched roof with insulation at the ceiling plane. I think that's the context of the question, yeah? Yeah, so this one's hard. This one's bloody hard. So ideally, you run you change the insulation and run it up your pitch. So run a warm roof system. That'd be the best way to do it. Keep all your critical structure on the warm side of your construction. With rifle range, we were debating that really a lot because the tiles were in decent nick. It was going to cost tens of thousands to take them down, put a membrane up, put the insulation at a plane. So we actually left the insulation at the ceiling plane, put the airtightness membrane on the underside. So we've precluded that air transport and diffusion up into that roof system. We've got the clay tiles with no sarking underneath on the roof truss. So you've got a highly ventilated cavity up through there. So from a moisture perspective, it kind of feels all right because I've got very little vapour I would expect to be driving from the interior towards that cavity. I've got high drying potential because of all the gaps between the tiles. The problem then becomes the question of wind washing at the insulation, because ceiling insulation is a very low density product, as we know. It's very light and fluffy, sort of 10 to 12 kilograms a cubic metre typically. So it is far more sensitive to wind washing than your very high density insulations, like say a wood fibre board or a mineral, a rock wool type board, which are far less sensitive to wind washing, which is why I love those products so much, because I can whack them on the exterior of a construction and then you don't have to worry about a membrane, at least not from a wind washing perspective.
So how did you combat wind washing?
We didn't.
Yeah, how I said, like,
Yeah, we just I think we did. We also went under component method of passive house. So we weren't seeking the traditional method of passive house. So we only really needed to match certain criteria, with windows being the most difficult on an old building because we couldn't change where the existing windows are.
So maybe just to add a little bit to that. So what did you put? We put R6 or something in there, didn't you, Matt? Yeah, obviously a fairly decent level of insulation, but not much beyond code, because code requires, R5 in our climate anyway. So yes, it is going to be significantly derated by the wind washing, but what is the rate of wind washing? What's the air infiltration through that roof space? Well, it's variable, depends on how windy it is, depends on the temperature gradient and any number of things. And this just comes back to this thought that Dan was making about using Woofy, this hygrothermal simulation software. It's fantastic. Woofy is so cool to play with, but it also just throws questions at you all the time. And what I love about Woofy really is it makes you think, because you run a simulation and go, why is it doing that? And then you run sensitivity analyses and you say, well, what if I do this? What if I change the ventilation rate in the cavity to that? What's this assembly really sensitive to? What if I change the cladding colour? Any number of variables, because these simulations are so sensitive to so many things, and so many things are complete and utter bloody guesses. And this is where I think you end up having to come back to first principles all the time and say, well, does this, in a heating-dominated climate, have I got increasing vapour permeability as I move out through that construction? If you've got that, you're 90% of the way there in cold climates. And in the reverse, in Cairns, yeah? Problem is, of course, here, we switch from one to the other seasonally, so it gets a bit trickier. It's only where you've got those really problematic assemblies where the architect or whatever, for whatever reason, you've got something where, it's been specified with glass wool towards the interior and then there's XPS or something on the outside. You see that all the time, right? That is a recipe for disaster. You don't have to woofy it to know that that's like, shit, don't do that. But Woofy really just makes you think about what is the balance here, that heating and that wetting and drying cycle. What's the combination that's going to make wetting worse? What's the combination that's going to make the drying better?
So does that mean with Woofy 2D we should be able to then answer James's question?
which one?
Isn't there a new Woofy that's coming out that we can actually work out that space in the roof based off the sort of the volume?
The problem is with Woofy, I think we shouldn't dive too deep into Woofy because it's a bit too nerdy for everyone, I guess, here. But the thing is, what we have to understand is the reason is why we have this requirement in the building code that you have to ventilate 20 millimeters above your primary insulation layer, which is your ceiling insulation, is because programs like Woofy and other ones that can't calculate still standing air because it's something like a microclimate up there. So that's why you can't control it, so you have to ventilate it. Even back in Germany, so you heat it or you ventilate it to outdoor air, either or. So that's the important part, so you can't calculate still standing air. And you can say, yeah.
So let's say you're retrofitting your roof. And let's say it's like old hardened rafters, they need to be reinforced and the roof tiles are coming off. So you get this opportunity to create that secondary barrier. Would you put it on, like, to try and protect it? Like, because we're trying to minimise moisture getting into that insulation anyway, so we don't want it leaking through the tiles. So should we be putting that on, but then should we be designing the roof space to ventilate? Because still the primary insulation is.
So I think what James is saying here is if I'm taking the roof sheet off, be that metal or tiles, then what do we do in that scenario? I think I can't see why you're keeping the insulation at the ceiling plane in that scenario. Because I've taken the roof sheet off, the sheet off at this point, everything's in play, make it a warm roof. Bring my insulation up to the rafter pitch, put a vapour permeable membrane on the outside of that, put your ventilation batten, your counter batten, put your roof sheet, whether it be tiles, whatever, back on again, bomber system.
And if you do that, is it still cool to keep the Intello at normal ceiling height for your insulations? No, they've got to be all.
Yeah, I'd want them all at the same space, because you don't want trapped air gaps. You're going to have fun taping around all those penos, aren't you? Yeah, it's not fun.
Yeah, I think maybe we should have some other questions, but again, as I said, like, we really have to think black and white. So insulating the rafters, if you insulate between the rafters, the Intello should actually be directly attached on the smart vapor control layer should be directly attached because you want to protect it. Because if you have this massive air void, what's happening there? So if you have a lot of internal moisture, you just fill up all the space up there, and then you actually might increase the vapor pressure up there. So it means kind of, if you ventilate to the indoor air, because if the Intello is up there, you should actually then ventilate to the indoor air, so you have some kind of air movement in there. So I'm just saying is, put on the ceiling, ventilate it. I don't like the idea of ventilating it, so that's why building a skilling roof is the one and only way how to build actually a good roof structure. So whenever you retrofit, or when you build new, always try to build a skilling roof, rafter roof, whatever you're going to call it. If none ventilated, I know there are a lot of people who actually close up the roof structure completely, have the smart vapor controller on the ceiling, and close the roof membrane to the wall membrane, they don't have any problems. But the thing is now where we as a company, we can't give a defined answer to that. That's why we say we have to follow the building code in this case, because we don't know to 100% that it will work to 100%. And we always have to consider a building damage-free potential of the building.
So I was going to say, so we've got a pitched roof. Let's assume we can run the insulation flat, we can run the insulation up the pitch, we can put the airtightness membrane at the flat, we can put it up the pitch. Ideally, we all agree, I think the lowest risk solution here is to put both up the pitch. Job done, right. But then we've got the problem of how do we actually get that airtight membrane through all those pre-existing buttons or the structure. You could run the airtightness flat at the ceiling and then leave the insulation up high, creates this trapped air void, exactly as Dan's explaining. At least it's on the warm side of the construction though, because the insulation's north of that. It's a worry. It's definitely more risky than our first scenario. Our third scenario is to run the insulation at the ceiling and the air tightness, and then have our exterior membrane up the top. That's a riskier again scenario, because now our trapped air void is on the cold side of our construction. And so it's less tolerant, less able to carry that vapor build-up.
Complaining that we should change topics. The best way, yes, which is still relatively new, but I think the easiest way how to do it is you put insulation between the rafters, you run the roof membrane over it, maybe one with a high vapor resistance, and then you put another 60 mil of wood fiber on top of it, and then you don't even need the Intello layer, most likely. So whenever we retrofit roofs in Germany, we just put insulation between the rafters, an air tightness layer directly over the rafters, and over insulation wood fiber, because you don't need if the roof pitch is steep enough, over 12, 15 degrees, you don't need an additional layer of membrane. So the wood fiber board is actually a weather-tight layer too, and you can walk on it. And as a chippy, there's nothing better than to work with wood fiber. I love it.
So one more question.
You're very experienced now.
I am. So we've done this a number of times on projects where we've actually essentially learned from mistakes. All right. So first time we did our first passive house, we wrapped underneath it, and then we did our floor joist, which is an LVL, and then we chipboard on top. We tried a bit of a plastic wrap, didn't work. We then used some waterproof, kind of worked, didn't really work. The next project we did, we tried to two-coat the waterproofing system, a lot better. But still, again, we're finding a bit of moisture underneath the subfloor and getting in between that. What we actually did in that case there is we didn't completely tape it until the end of the project, so we still allowed sort of air to get in, dry it out a little bit. Now, the last time we actually did it, we actually used ProClima's new product, the Visto. Is that correct? Is that the one? Did Hero Visto? No water whatsoever. All right, easy install product. As a price comparison, on the money, because by the time that you sit there and you put that in and install it, and then you completely create a watertight layer on top, the amount of time that you get under there pulling out the insulation, checking it, making it dry, it was just easy to do it at that one sort of start point at the start of the project, and then off you go, and we haven't sort of worried about it. Now the question that people will ask, will your flooring glues and all that stick to it? There's been a number of testing done so far. We've actually found that by dragging the frame, working over it during the whole project, it's probably just going to be peeled up. And again, that cost also, our chipboard joints haven't, because there's no water or moisture sitting on top of them, they haven't sort of bowed up and they're quite flat. So now we don't have to spend $15 a square metre for a sander to come in and sand that joint back. So that cost has sort of negated itself, and we're sort of just back to square one. So sort of you're robbing Peter to pay Paul, but you're just doing it at the start of a project. And I think Hamish just used it yesterday or during the week, and he's, doing his little Instagram thing, pushing water off the side of the subfloor.
So it's obviously been raining the last few days, and Rory, who's up the back there, he's been running that project for us, and it's the first time we've used this particular product. There's 2 or 3 mil of water over the whole floor structure, and it's completely dry.
And so safe to walk on as well. It's
safe
actually
to
got a
walk
grip
on.
to it.
Yeah, it's totally fine. Just be careful on a cold day that moisture will get fucking slippery. But yeah, it's a game changer for us. My question to you guys off the back of this is, if we are using the Adhero Visto, now, just for the record, ProClima is a sponsor of Sustainable Builds Alliance, and so is Performance Membranes.
They are the best product on the market, though. Let's call it as it is.
Yeah, I still haven't got it for free. I'll push that agenda on my own house. But do we need to wrap underneath the joists?
Well, again, haven't we talked about windwashing?
Well, I'm curious to see what Cam has to say about this.
Yeah, I mean, for wind washing, obviously, rodent ingress, you would want to have a membrane there. Perhaps the question that I pose back, though, is should it be vapor open? That's what we do at the moment. We'll put to borrow Daniel's products, Exitana, Mento, I think is what you're keen on these days, because it's got the more reinforcing in it. That's vapor open. But if you think about a subfloor, that's a very moist space. And so think back to the vapor drive direction. Remember we were talking before about in the winter, the vapor drive across the wall is from in to out, and in the summer it's the reverse. Well, what is it in a subfloor? In a subfloor, you've got relatively high humidity, probably relatively low temperatures compared to ambient. And so the vapor drive direction might well be up all the time. And so you might actually, in theory, be better, and I'm not saying do this, put a vapor retarder underneath there instead to actually prevent the vapor drive upwards. Problem then, though, is the reverse. If you get the spill on the floor and then soaks into the timber floor through the chipboard and down, then can it get out? So, and I think the jury's a bit out on that, and you might say, well, let's woofie it, because everyone keeps saying that. Let's just woofie it, as if woofie can give you the answer to everything. And I'd say put to you that woofie gives you the answer to nothing, because it's just, there's so many assumptions you have to make. But it is still super duper useful, don't get me wrong. And one of the problems with a subfloor is you need an outdoor climate. So you need data on that subfloor, and if that subfloor's I don't know, Brunswick, where it might be very dry in that subfloor, or somewhere a couple of suburbs away where it's in the bottom of a valley and you've got lots of surface water sitting under that floor, you've got a very different outdoor environment and therefore different vapour drive.
Yeah, I agree. But 3 points for it. So first of all is, why is it so important to keep the insulation dry? So whenever insulation is getting wet, specifically glass fiber, you have to throw it out. And so whenever your structure is getting wet, the insulation loses the shape, it just will fall together and it won't insulate anymore. So that's why it's so critical and important to keep the insulation dry always. And when you look like on social media and also like on my efficient home thing on Facebook, like every week all my anti-con got wet, and even anti-con says it's not supposed to get wet. So insulation has to stay dry all the time. The next part is for the underfloor, yes, I always recommend using, for example, the Mento Plus in this car because it's reinforced. Use a reinforced product, so because the insulation has its weight, so the insulation will be hold in place properly. Also, I always prefer that you really fully insulate the floor cavity because you want the insulation attached to the inside for moisture transport. The other part is you really have to properly ventilate the underfloor. So if you, for example, plan to cover it up, then you need mechanical ventilation on the floor 24/7. But you really have to properly ventilate so you don't have this moisture buildup. Because then, my theory, is if you ventilate properly, then you have a consistent outdoor climate, even on the underside of your house. And, even more important, which is not a topic at all most times in Australia, is you might have to consider your ground conditions. So, just pointing back to Germany, that's just like we have worked for 20 years, is you might have to replace some of the ground with a different material. So if you have a very clay or earthy soil, it can absorb a lot of moisture. So very often you really need to allow that you maybe have 300, 400, 500 millimeters of gravel on top of it. So you really, that's easy for water to run off. And you have, the soil can't hold a lot of moisture. This will change the outcome significantly also. So what always would fill the underside up with gravel or something really, which doesn't have capillary.
Agree with that. I'll throw out a curly though, because I don't think you're ever going to be able to actually ventilate that subfloor such that you get ambient conditions unless you're like on stilts. Build a Queenslander or something that's, you know, quite high, particularly in, say, around here, where you've got a single front and you've got the side fence a metre away anyway. So even if you rip off the baseboards, you're still only 400 or 500 mil up. So are you really getting a lot of airflow through there? The thing that, if you look at some of the American stuff, so that Building Science Corp, they'll often talk about actually going the opposite direction altogether. Seal up the subfloor entirely. So run insulation down to grade, then put poly at the ground, so you're stopping that water from the ground moving up, insulate above that, and so your subfloor actually becomes a conditioned space, part of the house. A bit like you might do in your attic, where we were talking about before, where you suddenly put your insulation up the pitch, so suddenly you've got this conditioned attic. So create that subfloor as part of the house, and that's possibly the most robust way to do it. How you get that through the building code? Good luck.
Yeah, and in this case, I hate to say, but eventually, like the polyurethane stuff could actually work in this application. As much as I hate it, I would never recommend it.